Okay. Now let us come back to that problem, that first initial problem, that insect trapped inside a resin. So we will find out its apparent position, okay, using the relations what we have learned. Now for our simplicity purpose, we are considering that this resin item to be in the form of a sphere, okay, and this is the radius of curvature, this is the center of the this resin, let's consider resin droplet, and now or resin sphere, and somewhere here is the insect, here is the insect, okay. Now for our simplicity purpose, let me assume, now when you do maths these things will be provided to you. So I am saying that the radius of curvature, the radius of this sphere is around 5 centimeter, and this one, as far as we know, roughly we can know that the insect is lying at a distance of 2 centimeter from the surface, from the curved surface. So we are the observer here. So this is the observer who is looking at the object from N1 medium, and this is N2, okay. So we need to find out, for now let us consider that the refractive index of resin is equivalent to glass only, that is 3/2. This is our assumption. So what is the first assumption? The first assumption is that the radius of curvature, these are all our datas we are giving, okay, to understand the process how to solve it. So based on that, let us solve this. So you see, so this is the center of curvature, that means this must be the, okay, I will change the color of the normal, this must be the normal. Now a ray will originate from here and will get incident at the interface, correct? Then in the rarer denser medium it will move close to the normal, and the rarer medium it will move away from the normal like this. Is it or not? Hence the observer, well, it is the observer, let's the observer is here, let's say the observer is somewhere here. So the observer finds the image to be located here. So this is the image. We need to find out what is the position of the image. So isn't this the apparent position of the insect, and this is the object insect, okay. So how will you find out? You have to solve this, what is given to you. Let's see what is given. Our radius of curvature is given as 5 centimeter, u is given as 2 centimeter. What do you think, it is plus or minus? This is the DOL, this is the direction of light, so this must be negative, both of them must be negative, right? This is negative, this is also negative, because you are measuring opposite to the direction of light. Fine. Now which relation to use? Because we know two relations. First relation is that minus n1 by u plus n2 by v equal to n2 minus n1 by r. So should I use this relation or should I use this relation? n1 by v minus n2 by u equal to n1 minus n2 minus n2 by which relation to use, this one or this one? Now you think which relation to use. It is complicated. You will find it difficult to choose which one, this one, this one. Initially you will find it very confusing to choose whether this one or that one. In order to do that, that's why my trick comes into play. I'm not going to use this one, neither this one. I have given you a simple relation for this. That is, you always think 1 by u plus n21 by v equal to n21 minus 1 by r, right? So go to the next page. In this case the ray is going from denser to rarer. That means my relation will be what? My relation will be minus 1 by u plus n12 by v equals to n12 minus 1 by r. That's it. So I do not need to think whether I will be using this one or whether I will be using this one. I just need to follow n21 when it is going from rarer to denser, and when the ray is going from denser to rarer, it becomes n12. That's it. So n12 will be what? N12 would be n1 by n2. That gives me, in refractiveness of air, let's say, is 1, and that of glass is 3 by 2. So that gives me 2 by 3. So minus 1 by u. U is how much? Minus 2. So it should be minus 2 plus 2 by 3 v I need to find, and then again 2 by 3 minus 1 by r will be how much again? R is minus 5. You see, you have to opt for, although in the derivation you have used this sign convention, here also you have to use the sign convention during maths. Remember that. So this minus get cancelled. So half plus 2 by 3 v equal to 2 minus 3, that gives me minus 1. That gives me minus 1 by minus 15. So minus get cancelled. I am left with 1 by 15. So 2 by 3 v now would be equals to 1 by 15 minus 1 by 2. Next page. 2 by 3 v equals to 1 by 15. So I think LCM will be 30 only. LCM will be 30, and 15, 1 minus 2, 15. So that gives me minus 14 by 30. So this one gives me 10. So 2 by v is equals to minus 14 by 10, or this one gives me 2 sevens of 14. So 1 by v equals to minus 7 by 10, or v must be equals to 10 by 7 minus. So 7 1s are 7, 3 and 7 4, 1.4 minus 1.4 cm. Let us go back to the diagram now. So this distance is how much? Yes, we are right. Our maths is extremely correct. This is minus 1 point. How much I got? 1.4 minus 1.4 centimeter. If our maths was wrong, we would have got this plus. Correct? So this is how you solve the, that means the insect inside the resin block or resin sphere is at a distance of 1.4 centimeter from the surface, from the curved surface. So the person is looking at the apparent position, not at the real position. I hope you have understood this problem. We will do few more, 1 or 2 more in the next video. Okay, until then, see you.